Okay, here is our test review video for our Intro to Functions unit. This first section, we're being asked to graph ordered pairs. Remember that the first number is your x coordinate, the second is your y. The first one, x, is going left or right from the 0, and the y is going up or down from there. So if I'm trying to graph -3, 2, I'm going to start at the 0. This is kind of wonky. Hold on. Figure out where my axes are. So remember, this horizontal one is your x-axis and the vertical is your y. So I'm going to put my pen on 0 and I'm going to go left 3, up 2. So left 3, up 2. And there's my first point. And I'm just going to do the rest of these. Pause your video and go ahead and do the rest and then come back. Okay, so here are my points graphed. And so I did that. The next one says determine if the relation is a function. A function is where every x value has only one y value that goes with it. You can figure that out here two different ways. You can look at the ordered pairs up here and see if any of the x's repeat, and I see that the -1s repeat and their y's are different. So I could go ahead right now and say no, it's not a function. And I could say because x's repeat. Another way is to use the vertical line test. So if a vertical line goes through more than one point anywhere on the graph, then it would fail the function test. And right here, this imaginary vertical line goes through 2 points at the same time. In fact, that's where the x was the -1, right? It had one y that was 2 and had one y that was -3. So it fails graphically also. So I could also write here a different reason. If I wanted to, I could just put fails vertical line test. So then on this next one, we have a graph already given to us. We don't have to graph anything. And it says, does the graph represent y as a function of x? This just means, is the graph a function? And it kind of feels like no, for the same reason that we said here. A vertical line would cross through more than one point. It feels like that's happening here and here. But it's actually not happening because these are open circles. So a vertical line is really only going through one point still, and one point here as well. So we can say, yes, it is a function. And our reasoning is passes vertical line test. On this section, we're asked if this table represents y as a function of x. That's another way of saying, is this a function? So in this format, the x's are going across the top and the y's are going across the bottom. And we still want to look at, are any x's repeating? So I look at each one individually and none are repeating. So I'm going to say yes. And my reason, no x's repeat. Now, one kind of tricky thing here is the y's are repeating, and that's fine. That doesn't matter. We're looking for x's repeating. And then on this next problem, we're being asked to write a function using function notation A of t that best models the situation. So a plane loses altitude. Remember that altitude means height, at the rate of 5 meters per second. It begins with an altitude or height of 8,500 meters. The plane's altitude A is a function of the number of seconds t that pass. When you say something is a function of, it means that A depends on t. And that's why we have this function notation in this first problem. Write a linear function A of t that best models this. So this would be usually what our y would go, and this would usually be an x. Or sometimes we would, if we were doing actual function notation, it would be f of x, and remember that represents our y. So the plane would start at 8,500 meters and lose, so subtract 5 meters per second, and t is representing the time in seconds. So how many seconds before the plane touches the ground? So this represents the height. And when it touches the ground, the height is 0. So I plug in 0. And then I just solve this equation. I'm going to add 5t to both sides. Divide by 5. Come over here and do a little division. So 1,700 is my answer, and that is in seconds. On the back, we have some review problems from our previous units. Here we are plugging in the given values and then simplifying. So I have this negative that's in front of the whole expression or fraction. I'm going to plug in 2 anywhere I see an x and 3 anywhere I see a y. And now I'm going to follow my order of operations. This negative in front is going to be the very last thing that I handle. So for order of operations, I'm going to focus on my numerator first. I'm just going to come over here for a second. There's parentheses, but there's no math inside, so I don't need to do that. E comes next. There's no exponents. M comes next. There are 2 places that we multiply. So I'm going to do, let me get a highlighter. I'm going to do this multiplication first, the negative 7 times 2. That gives me 2 minus or negative 14 times 3. Do not do the 2 minus 14. I know you really want to, but you have to resist. We're not done with multiplying, okay? So we're still on our multiplication step. So now we're going to do the negative 14 times 3. Maybe you need to do a little bit of math over here. So that is 2 minus 42, and that is negative 20. So that was just for my numerator. So I'm going to go back here. I've got this negative from the front of the problem. I've got this negative 20 for my numerator, and then I have over 8. Hold on, I think I've done something wrong, haven't I? Oh, I found it. Good heavens. 2 minus 42 is not negative 20. That would be completely false. It is negative 40. So happy that I have erasable pens. They will change your life. If you have it in your budget to get erasable pens, go get some. Here's the brand. Friction Clicker. They're amazing. So now, remember I said the negative in the front we're doing last, so I'm doing this negative first. So negative 40 over 8 is negative 5. Then bring along the negative from the beginning of the problem. And negative makes positive, so my answer is 5. And then for this problem, we are simplifying. There's the number section, the A section, and the B section. So we're going to look at them individually. 32 over 4 is 8. That goes in the numerator because 32 is bigger than 4, so the bigger part stays on its side of the fraction. For the A's, there's most A's on top, so the A is going to stay on that side of the fraction, and 6 minus 2 is 4. And for the B's, there's the most B's on top, so it'll stay up there. 7 minus 5 is 2, so we end up with not having a denominator at all. For number 7, we have an expression in function notation. That's the f of x right there is function notation. And I'm being asked to find f of 3 and then f of m. So whatever's in the parentheses is what you're plugging in for the variable. So this equals 3 times 3 squared minus 5. Follow my order of operations and do the 3 squared first. That's 9. And then now do multiplication. That's 27. And now do subtraction. It is 22. Here, it's not a number. in the parentheses. It's not an x either. It's a completely different variable, but you're still doing the same thing. You're taking whatever's in here and you're substituting it in for the x. So 3 times m squared minus 5. You could leave it like that or just write 3m squared minus 5. These next two problems are for the calculator to find the linear regression, the line of best fit. So I'm not going to talk about those steps here, but I do want to talk about writing it in function notation. So instead of f of x, remember this is usually our x column and our y column. Y depends on whatever x is, but this time we have that dollars depend on hours. So function notation would be the D on the outside and H on the inside. So function notation is D of H, and then you would use the calculator to get the equation that goes here. I want you to take a second and pause your video. Oh no, never mind. I was going to say write your own function notation here, but it's actually given to you in the problem. This is usually our X column, and this is usually our Y. This information depends on this information. So the C, number of cans, depends on T, the temperature in Fahrenheit. So that's your function notation, and then you would use the calculator to get the equation. Remember, you need those calculator steps memorized. You can find that worksheet in your Google Classroom for earlier in the week. And then this last problem is another review from a previous lesson. Alex scored 75, 70, 85, 90, 100 on the first 5 tests in his math class. After the semester exam, which is counted twice, his class average is an 85. What did Alex score? So we are going to, so remember, to take an average means adding up all the scores you have. These are my known scores, and then I have the semester exam, which I don't know, and it counts 2 times. So I'm going to write it twice. That adds up to 1, 2, 3, 4, 5, 6, 7 grades, which all average 85. So adding these things gives me 420. Adding my x's gives me 2x. From here, I'm going to multiply both sides by 7. They cancel on the left, leaving me 420 plus 2x equals 85 times 7. That's 5, 3, 56, 595. Minus the 420 to both sides. 2x equals 175 divided by 2. X equals 87.5. We'll just round up to 88. There we go.